Hello and welcome in this new video. In this video, we solve the question number 6, assignment third of data science. Define overfitting and underfitting in the context of machine learning model. Describe how these issues can be identified and list strategies to prevent the mitigate them. Machine learning, underfitting and overfitting. Machine learning models aim to perform well on the both training data and new unseen data and is considered as a good. If it learns patterns effectively from the training data, it generalizes well to new and unseen data. It avoids memorizing the training data, overfitting, or failing to capture the relevant patterns under the fitting. Biased and variance in machine learning. Biased and variance are two key sources of error in machine learning models that directly impact their performance and generalization ability. Biased is the error that happens when a machine learning model is too simple and doesn't learn enough details from the data. It is like assuming all birds can only be small and fly. So the model fails to recognize big birds like ostriches or penguins that can't fly and get biased with the prediction. This assumption make model easier to train but may prevent it from capturing the underlying and complexity of the data. High bias typically lead to overfitting in the underfitting where the model perform poorly on both training and testing data because it fails to learn enough data from it. Example, a linear regression model applied to a dataset with a non-linear relationship. Variance error that happens the machine learning model learn too much from the data, including random noise. A high variance model learn not only the patterns but also the noise is in the training data, which lead to a poor generalization of unseen data. High variance typically lead to overfitting, where the model perform well on the training data but poorly on the testing data. Underfitting and overfitting, the core issue. Overfitting in machine learning, overfitting happens when a model learns too much from the training data, including details that don't matter, like noise and outliers. For example, imagine fitting a very complicated curve to a set of points. The curve will go through every point, but it won't be represent the actual pattern. As a result, the model works great on the training, but it fails testing on a new data. Overfitting models like a student who memorize answer instead of understanding the topic. They do well in practice test, but struggle in real exams. Reason of overfitting. First is high variance and low biased. And the second, the model is too complex and the size of the training data. You can see in the graph. Underfitting in machine learning. Underfitting is the opposite of overfitting. It happens when a model is too simple to capture what's going on in the data. For example, imagine drawing a straight line to fit point that actually followed a curve. The line misses most of the patterns. In this case, the model doesn't work well on either the training or testing the data. Underfitting models are like you, student who don't study enough, they don't do well in practical test or real exam. The overfitting model is high biased and low variance. Reason of underfitting. The model is too simple, so it may be not be capable to represent the complexity in the data. Second one is to the input features which is used to train the model is not a adequate representation of the underlying factors influencing the target variable. Third one is the size of training datasets used is not enough. Excessive regulation are used to prevent the overfitting, which constrain the model to capture the data well. Features are not scaled. You can see in this graph. Let's visualize, understand the concept of overfitting proper and fitting overfitting with the underfitting. High biased underfitting and low biased variance and high variance. You have seen this graph. The underfitting is straight line trying to fit a curved data set but not capturing the data pattern and leading to a poor performance on the both training and test set. Overfitting, a squiggle curve passed through all training points and failing to generalize the performance well on the training data but poorly on the test data. Appropriate fitting, curve that follows the data trend with a overcomplicating to capture the true patterns in the data. Thank you.